For innumerable generations humanity has gazed upward at the expansive stretch of the nocturnal heavens filled with wonder, regarding the cosmos's numerous, unresolved enigmas. In the 20th century, researchers proposed the Big Bang hypothesis, endeavoring to elucidate the inception, progression, and growth of the universe. Nevertheless, despite its widespread endorsement, this hypothesis continues to grapple with addressing some of the most essential inquiries about the cosmos. Recent revelations have introduced even greater intricacy to these celestial puzzles. For instance, in 2023, NASA's James Webb Space Telescope made a groundbreaking discovery. It identified cosmic entities that seem to predate the universe itself. This finding has left specialists astounded and ignited a debate on whether it's conceivable for stars to exist for a duration surpassing the universe's age. This paradox challenges our current comprehension of cosmic phenomena. Does this anomaly suggest the necessity for a completely new framework of the universe? These questions and many others will be examined in this presentation. If you wish to stay updated on the latest cosmic developments, don't forget to subscribe, like the video, and activate the notification bell. Approximately 200 light-years from Earth, in the constellation of Lyra, resides a star known as HD 14283. What renders this star particularly fascinating is its exceptionally high velocity, moving at 4,483 km/s, which offers valuable insights into its tumultuous history. Around 1 billion years ago, during a period when our Milky Way was still forming, it collided with a dwarf galaxy that was home to this particular star. However, the most astonishing feature of HD 14283 isn't its speed but its age. The star is among the oldest celestial bodies ever observed, earning the nickname Methuselah in reference to the biblical figure who, according to legend, lived for 969 years. Initially, estimates suggested that its age was a staggering 16 billion years, but newer calculations have revised that to 14.46 billion years, with a margin of error of about 800 million years. This discrepancy creates a significant puzzle when compared to the current estimate of the universe's age, around 13.8 billion years, as determined through observations of the cosmic microwave background. This raises the pressing question: what is this colossal structure? How could a star be older than the universe itself, which seems impossible based on our current understanding? This paradox has led scientists to reconsider the accuracy of our methods for dating both stars and the universe, prompting further investigations into these astronomical mysteries. To better understand this issue, it's essential to recognize the challenges involved in calculating the age of celestial bodies. Stars like our Sun maintain relatively stable temperatures and sizes over billions of years, making their age difficult to determine with precision. Astronomers analyze subtle changes in a star's brightness and color over time, then compare these observations to theoretical models that predict the life cycles of stars. One key indicator for determining the age of a star is its rotation speed. Just as a spinning wheel slows down due to friction, stars gradually lose rotational speed. By comparing the rotation rates of stars of various ages, astronomers have developed mathematical formulas that allow them to estimate a star's age using a method called gyrochronology. Methuselah, the star in question, is indeed ancient. Based on current estimates, it is the oldest known star in the universe. Rather than pondering if it could be more than 2 billion years older than its surroundings, we can approach this from a different angle. Could it be that the universe is not as young as we once thought? Understanding the vastness of 13.8 billion years is no simple task. If we were to condense the history of the universe into a cosmic calendar where the Big Bang marks the striking of the New Year's bell, Earth would only emerge towards the very end of December 31st, while human history would only span the last few seconds of the year. Astronomers calculate the universe's age by studying light from distant stars that formed hundreds of millions of years after the Big Bang, while the universe continued to expand, creating the phenomenon known as redshift by evaluating both the observable distance and the expansion of the universe. The current estimate for the universe's age is 13.8 billion years. However, new research from the University of Ottawa has proposed an intriguing theory suggesting that the universe might actually be much older, around 26.7 billion years. Professor Rajendra Gupta, a physicist from the University of Ottawa, has presented a hypothesis that combines Swiss astronomer Fritz Zwicky's 1929 theory with new concepts in physics. His theory suggests that protons lose energy over vast distances in time, a concept that contradicts current data about redshift. Gupta proposes that by allowing this theory to coexist with the universe's expansion, we could reinterpret redshift as a hybrid phenomenon not solely attributed to expansion. This reinterpretation could lead to a new estimate for the age of the universe, potentially offering solutions to long-standing cosmological questions, some of which have recently arisen in the wake of NASA's findings. Gupta's work builds upon the tired light theory and the concept of evolutionary interaction constants originally proposed by theoretical physicist Paul Dirac, suggesting that certain cosmic interactions may have evolved over time. It's important to note that our understanding of the universe's age has evolved over the years. For instance, in the 1920s, Edwin Hubble proposed that the universe was only about 2 billion years old, but subsequent observations have dramatically increased this estimate, eventually reaching the current consensus of 13.8 billion years. Regardless of whether we consider human history as a mere 10 seconds or 5 seconds on the grand scale of cosmic time, it is clear that the universe is extraordinarily ancient. Its continual expansion forces us to reevaluate earlier suppositions regarding its age. At the same time, intriguing new findings are emerging about our own Milky Way galaxy. Recent assessments show that stars located in the outer zones of the Milky Way traverse space at considerably reduced speeds compared to those in other galaxies. Several potential interpretations for this phenomenon have been proposed. One theory is that our galaxy may possess an unusually low quantity of dark matter, an imperceptible substance that plays an essential part in the gravitational interplay of celestial structures. Another possibility is that our present comprehension of dark matter and its cosmic distribution may be fundamentally flawed. This dilemma is rooted in data amassed by the European Space Ice Gaia satellite, which has precisely charted the locations of nearly 2 billion stars within the Milky Way. These observations have led astronomers to reassess their models of stellar dynamics, particularly within the galaxy's outer edges. The velocity at which stars move is a crucial element in estimating a galaxy's total mass, as gravitational forces acting on stars are contingent on the mass of the galaxy. Recent investigation using data from the Gaia mission indicates that the Milky Way's total mass, including gas, dust, stars, and dark matter, might be around 200,000 billion times that of our Sun. This estimate is nearly 5 times smaller than previous calculations. The reduction in mass could result from an unanticipated decline in visible matter within our galaxy, possibly suggesting deficiency of dark matter compared to prior assumptions. Nonetheless, calculating a galaxy's mass is incredibly intricate, and uncertainties may arise from either the Gaia data itself or the methodologies employed in the analysis. As additional insights emerge, researchers will continue to monitor these developments closely in the years ahead. Breakthroughs in technology, and upcoming space endeavors will likely provide deeper clarity on these unresolved cosmic enigmas. The James Webb Space Telescope, with its unparalleled observational capabilities, is poised to continue expanding the frontiers of our knowledge about the cosmos. It's not only the age of stars or the universe that we aim to decipher, but also the elaborate dynamics of galaxies, dark matter, and the forces that govern cosmic transformation. The universe's continual expansion remains a cornerstone of astronomical inquiry, yet, as we accumulate more evidence, we may realize that previous assumptions were incomplete or even fundamentally incorrect. A pivotal question we must ask is whether the principles of physics as we understand them are universally applicable across all scales and epochs. Could there exist undiscovered forces or phenomena influencing the behavior of galaxies and the lifespan of stars? As our observational instruments grow more advanced, we may uncover new dimensions of the universe that question even our most entrenched theories. Researchers are becoming increasingly aware that their knowledge of dark matter, dark energy, and the foundational forces might be far from exhaustive. Each new discovery, from remote galaxies to ancient stellar remnants, provides fascinating clues about the universe's structure, yet these revelations frequently spark more questions, pushing the limits of our existing knowledge. The notion that stars could be older than the universe, or that the universe may have existed longer than our current models suggest, urges us to reconsider our entire cosmological framework. This could necessitate the emergence of new physical laws, revised models, and potentially revolutionary ways of perceiving space and time itself. It also raises profound existential and philosophical inquiries about the essence of reality and our position within this infinite expanse. If these observations are validated, they would not only transform our grasp of cosmology but also significantly alter our perception of existence. As the debate over the universe's actual age continues, it's evident that we stand at the edge of a new epoch in astronomical discovery. The decades to come may hold the answers to mysteries that have perplexed humanity for eons, whether it's the possibility of ancient stars, the deeper secrets of dark matter and dark energy, or unforeseen cosmic forces. The universe still conceals many truths waiting to be uncovered. The road ahead is paved with inquiry, experimentation, and continuous refinement of our understanding. So even though definitive answers may remain elusive for now, the thrill of discovery is just beginning. Remain engaged for more insights into these paradigm-shifting explorations and theories. Keep your sense of curiosity vibrant. Who knows what unprecedented realms of understanding we might explore next? If you're eager to remain informed about the latest in astronomy and space research, be sure to subscribe to our channel. Click the like button and enable notifications so you don't miss any upcoming revelations as we delve further into the cosmic landscape. The future brims with the promise of transformative discoveries. The James Webb Space Telescope, with its cutting-edge imaging abilities, is set to be a pivotal force in unveiling the universe's secrets. Already it has begun to unveil astonishing new aspects of distant galaxies, exoplanets, and other cosmic occurrences. Yet this is merely the opening act. As Webb continues to navigate the cosmos, it might collect evidence that challenges our core assumptions about how the universe functions. One of the most exhilarating components of this ongoing exploration is the hunt for planets capable of supporting life, with fresh findings of exoplanets residing in habitable zones. The potential for detecting extraterrestrial life is more encouraging than ever. Although these findings don't confirm the existence of life beyond Earth, they pave the way for the tantalizing possibility that life may thrive elsewhere in the cosmos. The discovery of even microbial life on Another world would have profound ramifications for science and philosophy, reshaping our beliefs about biology, evolution, and our cosmic significance. Furthermore, as we deepen our examination of the elusive forces of dark matter and dark energy, our present scientific models will likely be challenged and enhanced. These mysterious components constitute the majority of the universe's mass-energy composition, yet their attributes and influence on cosmic structure remain largely veiled. Among the most compelling puzzles in modern physics is decoding the true essence of dark matter and dark energy and understanding their role in the universe's growth. Should researchers manage to unravel these mysteries, it could unlock revolutionary insights into the underlying nature of existence. In tandem with these astronomical endeavors, the behavior and progression of galaxies continue to be a prime area of focus. Observations indicating that stars at the fringes of the Milky Way are moving slower than anticipated have spurred experts to rethink the established models of galactic dynamics. This revelation may hint that our galaxy, and perhaps others, does not harbor as much dark matter as once theorized. If dark matter is less prevalent than previously believed, this could dramatically reshape our comprehension of gravitational laws and the cosmic framework. This scenario exemplifies how new data can prompt the reevaluation of long-standing theories, sometimes upending even our most fundamental cosmological doctrines. Likewise, the realization that galaxies might evolve in ways still not fully grasped underscores the importance of adopting a more intricate approach to cosmic study. Could the universe be significantly older than we assume? Are there epochs or events within its timeline we have yet to uncover? These are the kinds of questions researchers will continue to probe as they collect more information from current and forthcoming space missions. As the universe gradually discloses its hidden narratives, it's clear that our prevailing models are not the concluding chapter. Much remains to be explored, and with each revelation we're reminded of how vast our ignorance truly is. This enduring sense of curiosity and the relentless pursuit of answers are the true driving forces behind scientific exploration and discovery.